Good morning. Let's talk a little bit about Newton's laws. I'm going to separate this video series into three separate videos, one for each of Newton's laws. The first law is it's an easy one to understand because you've all experienced it. Think about sitting in a car. If you're sitting in a car and the person driving hits the brakes, your body wants to move forward in the motion that it was already moving at. So that's why we wear seatbelts, is so we can overcome that if we get into an accident. So if we look at Newton's first law, Newton's first law is also known as the law of inertia. And what he says, Newton says, is that an object that is not moving or is at rest will stay at rest, and an object that is moving constantly will keep on moving constantly at a constant velocity, which we know means at the same speed and the same direction, unless an unbalanced force acts on the object. So let's just, I'm going to show you a quick diagram, what I mean by that. Okay. So if we have an object, we'll say a ball, okay, and the ball is moving constantly at, let's say, 10 meters per second. Well, if there are no unbalanced forces on the object, that ball will constantly move at 10 meters per second forever and ever and ever. Now that's kind of odd, because on Earth we don't really experience that, because there's always forces that are pushing against stopping objects. But if this ball were a ball that were in deep space and moving at 10 meters per second, it would move forever and ever and ever. And it's pretty cool that we had Newton that really got into, he thought outside the box, and he decided he would think of an object that we're hurling through space. So the cool thing is, if you toss a baseball in space, it's going and going and going until another force acts on it. Now, we know that on Earth it's difficult to duplicate that, because we know as objects that stop. When we throw a baseball, it stops. When we kick a soccer ball, it stops. When we throw a football, it stops. So the inertia can be displayed in some situations on Earth, but it's cool to think about it in outer space. So objects that are in constant motion, they have no forces acting on them. Okay, no unbalanced forces acting on them. Now, if I have another object, we'll say the same ball, okay, that's not moving, so there's no movement, we can also say that that object likes to stay still. Not that it has a mind of its own, but it does like to stay still, and will only accelerate when a force is applied to it. So if I kick the ball, a force is applied to it, causing it to accelerate. Inertia, we've all experienced it in the car. Okay, again, like I said before, if you hit the accelerator pedal, your body goes back, because your body is used to staying still. If you hit the brake pedal, your body moves forward. Okay, that's because your body's continuing the motion. It wants to continue. And God forbid you get in an accident, okay, you come to a halt very quickly, and your body is still moving at 50 miles an hour or whatever speed you were going at. And quickly, there are three accidents that happen in a car accident. The first accident is the car hitting another object. The second accident is your body hitting the next thing in front of it, which hopefully is a seatbelt. And then the third accident that takes place are your internal organs actually hitting the inside of your body. So that's why it's important to wear the seatbelt, and that's why we have airbags. All right, that's about it for Newton's first law, and we call that the law of inertia.